This is problem 11. Once again, I'm going to ask that you do not write while you are watching the video. You can wait until the video is over to try the problem yourself to see if you understood it. Thus far, I've been emphasizing that you can prove the triangles are congruent to show the pieces are the same. Then if there's an additional statement, you can end with it. There are several ways to do this proof. I'm going to show two different methods in two different videos. In the first video, I will follow this method, but I will also show that there is a way that you can show that angle B is the same as angle F without actually going through this. A person who is very good at proofs will recognize different methods and be able to choose the one that is faster and more simple. In this case, this method will be slower. There will be more steps involved than the other method, but it will still work. You can watch both methods and you can see if you prefer one over the other. I am going to start with my givens with the hopes of proving the triangles are congruent, showing the pieces are the same, and that is where I will end for this proof because it is only asking for two angles to be the same. With overlapping triangles, which is the case here, I need to consider which triangles should I show are the same if I want angle B to be congruent to angle F. So I should be looking for triangles that contain that angle, and one obvious set is this red triangle here, triangle GCB, and this one here, triangle GEF. The other triangle set, which may be less obvious, is much bigger. It's this whole half here in green. Triangle GDF also contains this angle, and triangle GBD also contains that angle. So I need to either prove the green triangles are the same or the red triangles are the same, and then I can say that the pieces are the same. My approach to this, knowing that there are two triangles which contain this angle, is that I'm going to add all of the givens, and then I'm going to see which one am I closer to proving congruent. After the givens, am I going to be able to prove the reds are congruent easily, or am I going to prove the greens are congruent easily? And whichever one is easier, I will choose to prove that set is congruent. So once the givens are over, I'll see, do the little triangles, are they closer to proving congruent, or are the bigger ones closer? And then I will prove those triangles congruent in order to show the pieces are the same. Our first given is that BC is the same size as EF. Our second given is that DC is the same as DE. I'm about to use the segment addition postulate. I'd like to emphasize that I can only add sides and I can only add angles if I know that the two pieces that I'm adding are the same as each other. So I can't add sides together unless I know that the ones I'm adding are the same. In this case, I know that BC is the same as EF, and I know that ED is the same as DC, so I'm not going to be adding without having known that they are congruent. I have placed the fact that these are the same as each other in the proof, so now I can say that if I add them together, the total will be the same as well. If both of the blues were 5 units long and both of the reds were 10 units long, you would very easily be able to tell me that the whole thing, which I'm going to mark here in black, would be 15 units long. I am going to do the same thing without numbers. I'm just going to say that the blue one plus the red one, well, they'll be the same amount as each other. I don't know what that number is, but the blacks have to be the same. So in step 3, I'm going to say that BC, that's the blue one, plus CD, that's the red one, is the same as FE, that's the blue one, plus ED, which is the red. This is the addition postulate. And all I'm going to do next is just combine these two pieces. So if I add BC plus CD, if I add the blue and the red, that just gives me the whole thing, which is the black. So I can say the black side, which is BD, is the same as this black side, which is FD. This is the segment addition postulate. I just combined the two pieces. There is one more given. It is that angle 1 is the same as angle 2. I have used all of my givens. And now I'm going to, as I was saying from the beginning of the video, see which set of triangles am I closer to proving congruent. If I look at this little triangle, GFE, I'll notice I have one side that's marked. If I looked at the larger triangle, GDF, I notice I have this whole black side, and I also have that angle. I am closer to proving the larger triangle is congruent than I am the smaller. So my goal is going to be to see, is there anything that I can get closer to proving that this whole triangle on the right is the same as this one on the left, and I can actually add the reflexive side GD. GD is the same as GD. It's the same size as itself. That's the reflexive property. And from there, I can say that triangle FDG is the same as triangle BDG because I have side, angle, side. The first set of sides that I marked, those long ones here, were in step 4. The angle that I marked, 1 and 2, was in step 5. And the last side, the reflexive side, was in step 6. I have proven the triangles are congruent. And good news for me is that angles B and F are part of those two bigger triangles. So if the triangles are congruent, then the pieces are as well. That is what CPCTC states. I am done.